All right, welcome. I'm Dr. J.D. Armstrong. I'm the Maui Technology, Education, and Outreach Specialist, and I have the pleasure of putting together these monthly presentations by researchers and community scientists. Today's really kind of an exciting one. We had a great deal of excitement about having telescopes out in the parking lot during our annual open house. And so we decided, let's try to do that for one of the public talks and let the amateur astronomers have a little bit of time to talk. And I sent out an email to the heads of the amateur astronomy groups saying, well, find out who you want to have talk, and thinking that we'd have maybe one or two people, because everyone knows that in America the fear of public speaking is greater than the fear of death. Okay? And so instead of having one person, we had four all jump forward and said that they were willing to do that. And so they're going to each give a little bit of a short presentation on their flavor of amateur astronomy and what it's about. And then, skies willing, we'll go out and get eye-to-eye piece, which is really important. That's the real value of what we're doing. But you can learn a great deal from all four of these people. We'll start off with Rob Ratkowski, turn it over to Rebecca Sydney, or Becky. Then Casey Fukuda and Steve McGee will finish it up. So if we can give Rob a big round of applause.
How to use a clicker. Where do you put this clicker?
Just somewhere on your shirt. That's good. Okay. Forward, backwards, laser.
Okay.
Okay?
Oh, why wouldn't he laser?
Yeah.
As JD said, I'm Rob Ratkowski. I'm the chief instigator for Haleakala Amateur Astronomers. I'm going to give you a very brief history of how we came about and a very brief explanation of our site. Back in 2004, my friend Robert Zaleski, an artist in Makawao, said, hey, you have a telescope? And I said, yeah. And he says, well, let's go use it. So we started going out by the 21-mile marker on Kaupo. And for a couple of years, we went out there and did some observing, and we picked up a fellow like Casey Fukuda over here, and a guy named Thomas Ingalls and Robert Christensen. And we observed, and then slowly we migrated up to the 9,300-foot level of the Kalahaku overlook at Haleakala. And Robert Christensen had a friend named Roy Mayhew. And Roy did these astronomical tours that came in from the mainland. And he says, hey, can you bring some telescopes? We're going to observe from Haleakala Observatory. This is right next to the Mies Observatory. This was big time, kids. This was it. We finally got into the observatory. So we observed there, had a great time. It was a great night. Robert brought up a grill. He had poo-poos and drinks, and these people were having a great time. And this woman looks up. She goes, oh, damn, the clouds are coming in. She takes a step, and she goes, oh, my God, it's the Milky Way. So needless to say, that sort of sealed the deal. But while up there, I met a fellow named Mike Maberry, who's the associate director of the IFA. A week later, I called him, and I said, Mike, what will it take for us to observe from inside the observatory? So for a half-hour conversation back and forth and this and that, it basically came down to having somebody let us into the observatory, that's Mies, to use the bathroom. When I said, I know where the old gamma ray observatory is. Okay, the deal now is email me when you're going up, and that's good. Well, that went on for 6 months. We had a great time going up there, and we started aligning ourselves with the IFA and doing things. Remember, what was that? What was the comet impact? Deep impact, when we fire a projectile into the comet. Anyway, we expected 100 people down at MCC. We had 800. And then the following month, we had a preliminary science report, which was good. And then there was a big deal down at Kaumano Center, where a lot of people from Manoa and Hilo came over. And that's when we were told, we can give you a place up there to store your gear. Well, that started what happened. Well, this is where we were. in this shed right over here. A month later, we were told we have to move, and you can have the old Baker Nunn Observatory. Well, the Baker Nunn Observatory 20 years ago looked like this. This was the University of Wisconsin Gamma Ray Observatory. And you can see all the gamma ray sensors over here, and it was really good. But 35 years prior to that, that's what it looked like up on top of the mountain. That was the observatory. This was the Baker Nunn site where they had a 12-inch Baker Nunn satellite tracking camera. This was one of the 12 sites on the face of the Earth. I would have loved to have been up here at that time. I mean, just to be in that spot, in that desolation, absolutely great. But anyway, we ended up getting the Baker Nunn Observatory, and this is what it looked like after we had cleaned it up. Okay, we have filing cabinets and stuff. You can't see all the other stuff. There was, what do we have here? Four polishers and tubing and pipe and all kinds of junk. Anyway, we were given a little money, so we started tearing it apart. You can see that we now put in some recessed lighting, took the ceiling out, started putting up parts of the wall over here where we're starting to get ready for the drywall. We put the drywall up. And the reason Gary Durish is pushing on John Pye's back because he is putting screws into bluestone concrete. Yes. But anyway, all that work, this is what we ended up with. So we have something that looks like a professional observatory, so when the kids come in, they don't think it's Club Haleakala. So now we work here, we enjoy here, we love it up there. We thank you, IFA, Jeff, and we appreciate it. But now, Becky, you're on, babe. Oh. I'll clip that someplace. Clip this someplace.
Thank you for covering me.
Mm-hmm.
Oh, I can't clip it.
Just up in your pants. And you know the laser and forward. Black button over.
All right. Aloha, everyone. I'm Becky Sydney. I just want to first extend a big thank you to Dr. J.D. Armstrong and actually all the staff here at IFA. Thank you guys so much for having this facility and reaching out to the community, especially us amateur astronomers. We love it here and appreciate it so much. Thank you. And as president of the Maui Astronomy Club, any Maui Astronomy Club members? Yay! All right. Thank you so much for coming. Thank you. Well, I know the members definitely want to thank you guys for letting us use the Falks telescope. We got to use it a couple times last year, and we were observing galaxies that were as big as this monitor here. And you'll see some photos as we go. But it's just so thrilling, and everybody was just awestruck, and it's just awesome. Thank you guys so much. All right. 20 years ago, when I started as amateur astronomy, I was so enthralled with the night sky, especially moving to Maui. You see this beautiful dark sky. You know, people from all over the world comment how awesome it is here. Well, I was so excited. Like, for 2 years straight, I just studied for hours during the day. I would observe 5 nights a week, and I wanted people to, like, you know, hang out with who did the same thing or who was enthusiastic about the stars. So I looked around, and there was like no astronomy clubs really, so I decided to just create one. So just shortly after I got the word out, and pretty soon I was connecting with all kinds of people with telescopes and all different kinds of interests in astronomy, and we're all sharing and learning now. And oops, what did I do? Oh gosh, what did I do? Did I step on the cord? All right, thank you. Was it that? Yeah.
Just went to sleep.
Great. So we started the Maui Astronomy Club, and we've been going strong for 18 years. So we have like 250 members now, and we meet once a month, sometimes twice, sometimes 3 times, depending on what's going on in the universe. And I highly recommend if anyone would like to join. There's a sign-up sheet outside, and our next gathering will be on the 3rd of February. We're going to meet at the Whale Sanctuary. There's a woman, Tracy Latimer. She's like the meteorite lady on Maui. I don't know if any of you know her. She's going to give a presentation on meteorites. She has a collection. she's going to share it with everybody. So that's open to all, and we're going to have a great year this year. A lot of things lined up. All right. So bottom line, amateur astronomer, it's all about love. Isn't it? You love the stars, right? You love the planets. You love constellations, galaxies, supernova, black holes, the universe, right? That's what you love, right? Well, it takes that and wanting to learn more and discovering things and exploring it. That's what amateur astronomy is. Passion for stars and observing and learning, and it's a lifelong passion. You could live 10 lifetimes and not learn all the stars. So, and there's all different kinds of interest in astronomy. I looked up on Wikipedia. I was really curious, how they defined amateur astronomy. And the first line was, amateur astronomy is considered backyard astronomy and stargazing. I went, okay, yeah, it is that, but it's so much more. It's a broad, broad spectrum. If you have this end of the spectrum, you have beginners, people who just want to go out into their backyard. They want to say, oh, I know that star, that constellation. They know how to find the planets. They know how to find the North Star. They know the phases of the moon. The beginner stuff. You got to learn the stars, right? That's half the fun. And I always try to recommend for beginners, try to spend extra time learning the zodiac constellations, Aries, Cancer, Capricorn, Scorpio. This is the main part of the sky as like a clock or a calendar or a way to navigate or to know the seasons, to chart the equinoxes, to know where the main stuff is. Because it was the ancient people who figured out the sun's path and the stars behind it marked this, what they called the royal path. We call it the ecliptic. It's the path of the sun. But not just that, the moon and the planets are all on this path. And they move through the stars, just the zodiac constellations. You would never see Jupiter in the Big Dipper. And if you're going outside and you want to find the planets, the ecliptic, it only runs east to west. So you don't have to look north or south for anything. You can cut out half the sky and just go look east to west. You're bound to find a planet. So it's really, really important to learn the ecliptic. In the summertime, the ecliptic, what happens is the Earth is tilted 23 degrees. So the ecliptic, it looks like it shifts 23 degrees this way, and then it goes back to an equal zone, and 23 degrees this way, equal. So it does that throughout the year. So the furthest northern position of the ecliptic, if you were to mark where the sun sets in the west, that would mark the first day of summer. That is the solstice. It's the furthest position of the sun on the ecliptic, and it happens to be in the sign of Cancer. So if you ever look at maps or globes, you see a little dotted line called the Tropic of Cancer. So that's how that came about. That's the most northern position the sun will set throughout the year, and it happens to be the first day of summer. So then it goes to the equal part. You get an equinox. Further south, you get the winter solstice. It's in the sign of Capricorn. One more reason why you need to learn this ecliptic zone. Very important if you want to chart the equinoxes and the solstices. So very, very important in astronomy. And the best way to learn the stars, I think, Steve, you're going to talk about planispheres, right?
Yes.
Okay, so that's definitely one way. A planisphere is like a star chart. But you have, I think, this in your handouts. These are free. You can go to the Bishop Museum website, download for each month. So it shows you Maui sky, because if you were to use a star chart with a 30 to 40 degree latitude, you wouldn't see all that we see in Hawaii. So when you change your latitude, you see less or more stars, depending on which way you go. But this is how you want to learn the stars for each month. This also has the Hawaiian names for the stars, which is always really cool. When I first started astronomy, I was really into the star names and what they meant, like Albireo, Betelgeuse, Deneb, those names, The star names, most of them are Arabic in origin. So when you learn these names, like Albireo, It means head of the swan. So when you look up in the sky, you find Cygnus the swan. Albireo marks his head. So the star names, the meanings, tell you and describe what part of the constellation you're looking at. Deneb means tail, the tail of the swan. So you know immediately, once you learn the stars, you can learn the constellations easier. You sort of have an idea of what the names mean. Like Betelgeuse. This is a funny word. It comes from the Arabic word, see if I can get this, Bed al-Jaza. Bed al-Jaza. And that means armpit. So if you ever see depictions of Orion the hunter, he has 2 arms, 2 shoulders. This one is not Betelgeuse. This one is. His arm is up. You will see his club. It goes up, the armpit. But let me move on to show you some of these here. This is what really got me into astronomy. Seeing these, the Hubble pictures. This is the ultra deep field. All points of light on this image are galaxies. So it's pretty mind-blowing. This is the another star chart. And is this free, JD?
Yeah, this is free.
So you can download this. This is a really pretty star map. Very different, huh? So this is also, there's websites down here. And wow, that's a very colorful one. I have not seen this one. I like it. It shows you the planets. Here's Jupiter and Uranus right next to each other.
Is that on the IFA site? That's on the IFA site.
I love this.
If you search IFA star chart, you'll find it as one of the first 2 or 3 links in Google.
So that's, yay, Saturn's coming. That's so exciting. Okay, let's go on. This is the zodiac constellations that I was referring to and how important it is, and how from the Earth's perspective we see the sun in different signs. So this is how you mark the equinoxes. You know, the Earth has a wobble effect. So the alignment of the sun during equinoxes is shifting, or it has been shifting. It's a constant shifting during this, the precession of the equinoxes. It's all based on aligning with the stars in certain regions of our orbit around a star.
What's that new one on top?
Oh, yeah. That one would go like
How do you say that?
Ophiuchus. That's how I say it. Ophiuchus. The healer. The healer. He's the healer.
13th one.
Well, that one up there that's Sagittarius, but Ophiuchus sits about right here. It's kind of like above Scorpio. So some of the planets, they sort of go at the bottom of Ophiuchus. There's a few stars that, the planets will go up into this region. It's Ophiuchus, but it sits above Scorpio. Kind of fits right in there. So yeah, that's pretty interesting. 13 signs. And this is how you can mark, the equinoxes are where the ecliptic and our equator cross. And then the solstices are when they're furthest apart.
What color is the equator?
Our equator? Or the ecliptic?
No, the celestial equator.
Let's see, which one would that be? Let's see, we have the ecliptic is red. The white one, yeah. This is the ecliptic here, and this is our celestial equator. Looks like an atom, doesn't it? Okay, now we're getting into an area, part of the spectrum of astronomy. There's lots of different interests, and this is where you're going to spend money. Instruments. And we could talk for hours about instruments. There's a lot to be said about them, but one instrument that you guys, if you're just starting out and you want to look at the sky and see nothing but fields of stars, get binoculars. Binoculars will blow you away. You will see so many stars. For hours and hours I would use binoculars and you can move easily with them. You can scan, you can go up and down, and it's just wonderful. It'll cost you maybe $300 for a nice pair of astronomical binoculars. We have some outside in the parking lot too, so you guys can check them out, see if you like them. You have to have a mount, though, and a tripod. They're way too heavy. You can't hold them still. So another $200 maybe for a tripod. But definitely binoculars are the way to go. This is called, there's 3 basic types of telescopes for amateurs. refractors, reflectors, and what are called catadioptric. They're like Cassegrain telescopes. This is a refractor. It uses lenses instead of mirrors. You'll see this kind in Costco, I think. They're the real long, skinny tubes. They're smaller. I have a hard time using these because they're small, but I need something bigger. I use a scope like this. This is one of the Cassegrains. This is a Schmidt Cassegrain telescope. These have shorter tubes because there's mirrors in there, and it has a sealed tube so dust doesn't get in, which is really nice. A lot of these come with GPS. They're computerized. You just punch in Saturn and, it goes right to it. That's called the lazy man scope, okay? No, I'm teasing. They're awesome. There's hundreds of thousands of objects, stored in this computer. And here's the other kind. This is the one that I recommend for beginners. These are very robust. They're easy to use. It's a reflector telescope, but this telescope is called a Dobsonian, and an amateur astronomer created it, John Dobson. John Dobson he's revolutionized amateur astronomy. His goal in life, and if you guys ever go to Wikipedia, his story is so interesting. Does anybody know his story? He was born in China, and then he was an atheist, and then he was a monk for 20 years, and then he invented this scope, and it's really a cool story. He's neat. But he's an amateur, and look what he's done for astronomy. These are like $300. I recommend at least a 6-inch telescope, and 8-inch is great. The bigger, the heavier. So I have some big scopes. I can't even use them. I can't pick them up, So keep that in mind if you're buying a scope, okay? Just something you can transport. And you can spend so much money. I mean, I think Rob, where's Rob? Don't you have a lens that's $1,000 or something? Just an eyepiece, $1,000,
No eyepieces are expensive.
Oh, okay, but there are.
I refuse to spend that.
But there really are. You can really spend a lot of money on this. I have a friend who has 15 telescopes, and pretty serious guy. Next part of this spectrum, there's so many different things in amateur astronomy you can get involved in. If you like photography, astrophotography is the next thing you want to do. This is where I want to get started in, because I don't know anything about photography, and I have a camera and I put it up to my telescope during a partial solar eclipse, and I just put a little digital camera up to my eyepiece, and I got that shot. So not bad. I mean, you can get really serious and get a CCD and have it attached to your scope, and you have to have a computer and software, and it takes the images, and that's great too. That's more serious, but astrophotography is really taking off now. It's so easy. You have a question? Yeah, this was a partial solar eclipse. I took that picture here, right in the parking lot last year. It was really cloudy, and it just happened to clear right when the eclipse was happening, so that was really cool. This is a picture I took through my binoculars. So I just put my little digital camera up to the eyepiece, or the eye, and so it's really fun. You can play with it. It's so cheap nowadays for cameras. And I have a friend in Iran. Every week he sends me his astrophotography pictures. This is a beautiful temple in Iran. Look at the full moon. I mean, he is so good. He's more of an artist, This is his photo of the moon, Venus, and Jupiter, a triple planet conjunction right there. I think that was last year. You guys remember that last year? Yeah. And this is not using a telescope. This is astrophotography just looking at the sky, right? No instruments. This is another picture from Iran. Look at the solar eclipse on the temple floor there. It's just so beautiful. Yeah, he's very interesting. Iran and Iraq, that was the Fertile Crescent. That's where astronomy, the Arabs were the first to really name the stars. Those names stick today, so they're very into astronomy there for sure. This is a picture I took up at Haleakala when Jupiter was at its closest approach last year. You can see the moons. I swear I just put my little digital camera right up to the eyepiece. And so nothing fancy for me, but I'm going to learn. I'm going to be learning CCDs and all of that this year, so I'm excited. Here's another picture from Iran, but look at Orion the Hunter. You can see just the stars, and here's Sirius, the dog star. So that's a really neat way to... This is a picture of the North Star, and just leaving the aperture open, all the stars streaking around it. Stars that circle the North Star are called circumpolar stars. And 2,500 years ago, when like the Polynesians were voyaging, they didn't have a North Star. They didn't have that as a North Star. Because the Earth wobbles, you remember that wobble effect? Well, if this is the axis and the Earth is wobbling, you know, whatever star is pointed with or aligned with the axis is the North Star. We are very lucky. We happen to have a star aligned with the Earth's axis. It's a degree off. It's not perfect, but we still have stars that are circumpolar around a central star. 2,500 years ago, the axis was aligned to just empty space. In the year 12,000, the North Star is going to be the star Vega, which is going to be awesome because Vega is super bright. The North Star, you guys, please, 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 don't tell anybody it's the brightest star. I hear that from so many people, but I was taught in school. It's like the 50th brightest star. It's pretty low on the list. Anybody know the brightest star? Sirius! Wow, awesome. Anybody know the second brightest? Canopus. Canopus is my favorite star. And we'll see it tonight, I hope, and wait till you see it. Yes?
I thought the brightest star was the sun. Yes.
But here's more astrophotography. It's so cool. This is a globular cluster. This is 1 million suns, that are gravitated into a ball. This photo was taken through a telescope, I believe, right? Yes? This is from Rob Ratkowski. Rob took this photo. This is like the best picture of Omega Centauri I've ever seen. Like, it doesn't really do it justice on this monitor. When you see it, it's really beautiful and clear and sharp. Something about this object here, I'm just going to say real quick. Globular clusters are a type of object. Like there's nebulae and planets and globulars and galaxies. Well, this particular globular, they wrote an article, I think it was last year or the year before. They're discovering that this was the core of another galaxy. That our galaxy pulled in and stripped away the arms and everything, and the core is right here. So I think that's so cool. We're learning so more. I'm telling you, I cannot keep up with astronomy discoveries. Isn't it crazy? Do you guys hear about them? Like, I mean, there's so much. This is a picture that the Maui Astronomy Club took using the Phelps telescope. Look how beautiful. This is called the Sunflower Galaxy. That's 65 million light years away. So we're going to be using the Phelps again this year, so I hope you guys can come and join us. It is so wonderful. All right, let's get back to the spectrum of astronomy. We have beginners and learning the stars and learning the constellations and learning the ecliptic, using telescopes, using binoculars. I love binoculars. Using a camera, getting a CCD. Well, this part of the spectrum I want to talk about now are the guys that are way over here. I call them the serious dudes. These are the real serious astronomers who, they're the ones who are making their own telescopes. You know, it takes years sometimes to grind a mirror and code it. You know, these guys are like really into creating their own scopes. They have CCDs, they have cameras, they have software. You know, they're imaging the sky all the time. They're discovering things. They're using like university instruments or other observatories to do their projects and research. And they're discovering things, you know. Those are the very serious astronomers. And this, do you guys recognize this comet? It was in 1997. That's a big clue. Nope. Hale-Bopp! This was was discovered by two amateurs, Alan Hale and Thomas Bopp. Alan Hale was a huge comet hunter, very serious astronomer. Thomas Bopp was just out with his friends in Arizona partying, using a telescope, and he saw it at the same time as Alan did. So they got so the real serious guys, they contribute a lot to professional astronomy and the field in general, to the world too. The whole planet saw this comet, the only one in recorded human history that was the most seen comet. If anybody remembers the year before Hale-Bopp, does anybody remember the comet that was the year before Hale-Bopp? Yes, Hyakutake. This, oh my gosh, did anybody see this? Was it glorious? It was glorious. I thought it was so much better than Hale-Bopp. Look at that long tail. It was clear across the sky. It was just so amazing. I got to observe it for like 4 hours every night with scopes, but now I wish I would have known astrophotography so I could have taken some pictures. But yeah, this was not only discovered by an amateur, but he was using binoculars. So he discovered this just with binoculars. So I'm telling you, they're a good way to go. This, has anybody heard about this, Jupiter losing a stripe? This was discovered by an amateur astronomer, Anthony Wesley. He watches Jupiter like a hawk. And when Jupiter went behind the sun, he waited. And then the first night when it came out from behind the sun where Earth could view it, he was the one to report the missing stripe. It's still missing. Hopefully we'll see Jupiter tonight. It's out in the western sky. Still a mystery. Nobody knows why. Did Jupiter heat up? That's kind of like the leading theory, Jupiter heated up because the darker the color, the cooler the gas. So if it went from dark to white, it probably heated up perhaps. Maybe a layer collapsed. Maybe there's another phenomenon we don't know. So Anthony wants to be the first one to see it return because it will probably return. We'll see 2 stripes again on Jupiter. But folks, you got to see it through a scope because it may be the only time in your lifetime where you see Jupiter just with one. It's pretty rare. All right. Anybody hear about the little girl, 10-year-old girl, who discovered a supernova? A 10-year-old girl from Canada, Catherine Aurora Gray was her name. And she's at this end of the spectrum where she had lots of data and software, and she was analyzing all of this stuff from her dad, the images he took. And this is not the picture that she used. I just use this as an example because this is a supernova next to a galaxy, and that's what she sort of discovered. It was a supernova. I think it was in a galaxy, but this is how it would appear. But yeah, thank you guys so much. If you have any questions later, or come outside and view through the telescopes, and join the Maui Astronomy Club. Thank you so much. And now, Casey Fukuda will be giving a presentation. Here, I need to give you all of this. I can turn around because it's kind of... Hey, does anybody know what a light year is? It's a year with half the calories. that's a joke.
Hi, I'm Casey Fukuda. How you doing? Amateur astronomer. Let's see. I don't know how I'm going to follow Becky. She had so much information, but I'm going to just cover a couple of things about the night sky, what's out there, and what you can do as far as being an amateur astronomer without having any equipment at all. Okay? And let me get my notes here. We call looking up at the sky stargazing or naked eye astronomy. No binoculars, no telescopes. Becky was saying that you can live an entire lifetime and learn not even a fraction of what there is to know about what's up in the sky. And some people could learn, can study the moon for their entire life. There's just a lot of things to learn about the night sky. And one part that I'm going to touch on is basically constellations, okay? And why when you look up in the sky at one time of the year, you see some stars and some star patterns, and then 6 months later you look up in the sky in the same direction, and you see other stars and star patterns. Now, I know that's really basic, but there's a very good reason why that happens. So today, my talk is going to be about discussing what's up in the sky for naked eye astronomy, what constellations are, okay? And I know we talk about constellations, but there really is a definition for them. And then I'm going to talk a little bit about Greek mythology. I'm going to tell a little story about one of the constellations that are up there. And I'm also going to talk about, well, actually not talk. I'm going to have a little visual demonstration about why constellations appear in the sky at certain times of the year and why they don't appear in the sky at other times of the year. Okay? So when you look up in the night sky with no aid from any kind of binocular or any kind of telescope, you see basically stars, okay? And those stars, for astronomers, needed to be kind of divided up so we know when we're looking up in the sky where we're looking. And we do that using a road map or a series of sections carved out in the sky, and we call those constellations. Now, in those constellations, there are stars that make up certain patterns, okay? And the Greeks and the Arabs gave those star patterns names, and they actually attached images to those star patterns, and they called them constellations. So when you look up in the sky and you see all the stars up there, all of those stars that you see are in our Milky Way galaxy. That's the galaxy that's around our sun, that our sun is inside. You don't really see any stars from any galaxies outside of our galaxy. Okay? So you look up, see stars, they're in our galaxy. There's other things up in the sky that you can see with your naked eye, but really most of the things are stars. There's the moon, obviously, at night. There's planets. I think you can see 6 of them. Mercury, Venus, Mars, Saturn, Jupiter, and on some occasions, if it's dark enough and we're in opposition, you can actually see Uranus, which is a pretty far planet out in the solar system. You can't see Neptune. You can't see the planet formerly known as a planet, which is now a minor planet, Pluto. You can actually see some galaxies up in the sky with your naked eye. I think there's about 3. I might be wrong, but there's Andromeda, okay? And then if you're in the southern hemisphere, there's a couple of galaxies called, one's called the Large Magellanic Cloud and the Small Magellanic Cloud. Yes?
I thought you said all the things we see in the sky are part of our galaxy.
These are objects, okay, and clusters of stars, but you can't actually define the stars in those objects, these galaxies. But you can look up in the sky. Actually, I don't think we can see Pegasus and Andromeda right now, can we? Yeah, it's up in the sky now. And if it's a dark enough area, a dark enough spot that you're in, and you know where to look, you can see a little fuzzy thing with your naked eye, and that's the Andromeda Galaxy. Yeah. As a matter of fact, I believe the Andromeda Galaxy is the farthest thing you can see with your naked eye from Earth. Yeah. It's 2 million light years away. And so the photons that are hitting your iris at the time you're seeing it up in the sky left that galaxy 2 million years ago. Okay? There's globular clusters and open clusters up there. Basically stars, but groupings of stars. Usually you see them as like a fuzzy dot up there. Okay? The Omega Centauri, the one that Rebecca had a picture of, with all the stars clustered around a little ball. That one you can see pretty prominently in the night sky. And there are a bunch of other globular clusters you can see. And then there's some open clusters you can see. The probably the most famous one is the Seven Sisters, or the Pleiades. Pleiades, yes. Subaru. So, basically, up in the night sky, all you can really see is stars, because all that other stuff I was talking about is less than 1% of the objects in the sky. Okay, 99%, more than 99% of the sky is stars. Okay. Now, constellations are like a roadmap for astronomers, and they use it to find objects up in the sky using telescopes. And did we? Okay. So a constellation is a grouping of stars defined by specific borders, and astronomers use constellations to define areas of the night sky. Think of a constellation as a county on a state map, okay? And this was the best way I can think of to show you how constellations work. You can imagine this is, say, the constellation of Orion, this is the Sagittarius, but they're not next to each other, but that's how we identify the certain areas up in the night sky as constellations. And the constellations were given names a long time ago, and what I'm trying to do tonight is to help you understand why in June you look up in the sky, you see certain constellations, and why in December you see other constellations. Here's a constellation of Pegasus. And you can see the orange border that goes around Pegasus. That's the constellation. So it isn't just this square and these little stars here, but it's all these other things inside that constellation. So if we're looking for, say, M15, which is in Pegasus, okay, we can find this asterism right here and use some star hopping and get over to here and find that object up in the sky with our telescopes. Okay? And you can see that it borders Cygnus up here, Lacerta, Andromeda, Pisces down here, Aquarius, all other constellations. Okay? Just like the map on the state map I showed you. This particular star right here, Syrah, is actually in the constellation of Andromeda, but this box right here is an asterism or a grouping of stars that people can recognize because it makes a special shape, okay? And that's that asterism is called the Great Square of Pegasus, even though that one star right there is not in the constellation of Pegasus. Okay, so if you're looking in the night sky, you're looking for the Pegasus constellation, you can usually identify it by that square of stars. So then you need to ask yourself, what is up there? And it really depends, okay, on what time of the year when you're looking up in the sky. All right? I lost it. What happened? Okay, there we go. Oh, no, I gotta see the slideshow. Click from current slide. There we go. Okay. So I want to tell you a little story. It's a story from Greek mythology. It's about Orion the hunter, and I'm going to do a little demonstration after I tell a story about why or how the Greek gods put Orion in the sky and put his nemesis in the sky at a different time of the year, so they're not in the sky at the same time. The story of Orion. Orion was a great hunter. Okay. Hold on a second, see. Orion was a famous Greek hunter, revered and loved by the people of Greece for his great courage and hunting abilities. One day, out on a hunting expedition, Orion was taking aim at his prey, and he was stung by a giant scorpion, Scorpius. Now, Scorpius' sting is pretty lethal, and Orion fell to the ground with the poison in his veins. Well, luck would have it, Orion was hunting with his friend Ophiuchus, who's actually the physician constellation. And Ophiuchus took a snake, took the venom snake, serpents, and made an antidote, and he administered it to Orion and saved Orion's life. Now, the Greek gods, wanting to spare Orion any further contact with Scorpius, placed Orion in the sky so that he's only visible in the winter months, and then they place Scorpius in the sky, only visible in the summer months. And so, how did they do that? I wanted to show you a little quick demonstration, but I actually need a couple of volunteers to help me do this little demonstration. And I know Maya was going to volunteer one, okay? And I'm looking for actually volunteers for people that are less than teenage age. Can I get a couple volunteers from the back? What's your name? What's that? OT? And we got one more volunteer. I need 3 volunteers. It's really easy. Colton, got one more volunteer, please? It'll be worth it to you, I promise. Honest. No? Okay, I need one more volunteer. Thomas, I'm going to pick you as a volunteer. Okay? Do we have another person from the audience? How about you? Please, Thomas, we're gonna have him be our volunteer. What is your name? What is your name? Kenjiro? Okay. Kenjiro, you are Orion. Okay? You're going to be Scorpius the Scorpion. Okay? And Maya is the sun. What do I do with the sun? Hold on a second here. Here it is. Maya's the sun. Uh-oh. And Maya's going to hold the light on the top of her head. Right? Hold on to this, okay? So that she's broadcasting the light. Hold on, my clip came unloose here. Okay, so imagine this. We have the sun in the middle of the solar system, and I'm the Earth, okay? And I'm spinning around like this. I'm doing this dance, going in an orbit around the sun, okay? So when I spin one time, how long is that time? 24 hours, right? Okay, now if I go in a rotation all the way around the sun, how long is that? 1 year, okay? Now let's just say that my nose is Maui, okay? And I'm looking right at the sun, okay? What time is it?
12 noon.
It's noon, right? Okay, now my back is to the sun, and my nose is completely the opposite direction. What time is it then? Midnight, okay? And if I'm at this position right here, perpendicular to the sun, what time is it then? Dusk, right? And then dawn, right? Okay, so with Scorpius over here, right? Stand right here. We got Orion over here. So we're in January, which is the winter months. Orion's up in the night sky. So as I spin in, let's see, I got to do this right. I spin to the east, this direction, okay? All right. At night, I see Orion. But Scorpius is on the other side of the orbit. Okay, so I can't see Scorpius. So as I spin around, if I spin, this way? As I spin around the sun in the orbit, okay? 6 months later, I'm looking at night. Now what do I see? Scorpius. Okay, so I can't see Orion because Orion's on the other side of the orbit. Okay, so I'm spinning around here. So this is the summertime, right? Okay. Okay, now what month of the year, what season of the year is this here? Spring, right? I'm heading toward, no, actually I'm heading towards winter. So this is actually fall, right? Okay, so what is the constellation of fall? Anybody? Pegasus is one. Okay. Spin around here, Orion. Okay, going around the sun this way. Now this is springtime. What's a spring constellation? Leo. Sagittarius, Leo, Virgo, right? Okay. So this is the reason why the Greek gods put Scorpius over here and Orion over there. So they won't have to be in the sky at the same time. He doesn't have to worry about being stung by by Scorpius anymore. Yay. Okay? Okay. Okay, that was pretty heavy, huh? Now, as a reward for volunteering, even though I picked you, you get a new astronomy book. Sky Watching. The Stars by H.A. Rey. Okay, so I told you it was going to be worth it. Thank you very much. That was the end of my presentation. And next we have Steve. Steve?
I'll turn this off.
Turn the sun off? Don't turn the sun off.
Oh, don't turn off the sun. And how do you advance the slide? I just need to know. Oh, this. How do you advance it?
Forward. Laser. See laser? So
Oh, you got a laser pointer?
This is back, and that's forward. Yeah, it's a little red thing here on the black dot.
Okay. Hello, I'm Steve McGee. I'm with the Haleakala Amateur Astronomers. Now, you have a handout, okay? It's the middle one, okay? Now, I'm not going to cover everything on this handout. You can take it home, because if I sit here and just read it to you, it's going to be very boring. But I'm going to basically touch on everything in this handout, starting with at home, at the site, the observing session, and words that you write on your log, and sketches, and finishing up and summarizing, and then references. These references are very good. I can go over some of the references at the end if you like, if you have any questions about those. Also, I have a table up here of just about everything that I'm going to be talking about, and you're free to come up and have a look at any of the stuff, or I'm going to pass around a few things so you can look at them. So that's how I'm going to be doing my talk. So I'm going to clear the table here. Okay. Now let's see if I can get this to work. Nope. Aha. Okay. Anybody know who this is? Begins with G, 300 years. Galileo. All right, good. Okay, now before I begin, I just want to say no matter what level you are in looking at the sky, if it's naked eye, binoculars, small telescope, what I'm going to be talking about is applicable. Okay, what I'm talking about is recording what you see. Now, it's recording it in a way that when you give it to somebody, they can read it. They can understand what you saw, okay? There's a few techniques that I'm going to go through that show you, or that lead you through recording what you see, and I'll be talking about that. Also, these are simply recommendations. Everybody does it differently, okay? Don't expect that I'm giving you the gospel here of what you got to do, okay? This is just something that I've developed over the years, and it's sort of a way that I've followed where others have gone before me, okay? Now, I came to astronomy sort of through the back door. I'm not a trained career, degreed. Uh-oh. Whoops. What am I doing? How did I do that? I hit the button. Yeah, I just want to go back. I came to, actually, I first got interested in the sky. Oh, boy, did I go through all those at that one time.
That's impressive. I don't know how
That's a quick talk.
That's the back door.
That's the back door, yeah. I sailed to Hawaii in 1973, and one of my watches, back one. Yeah, one of my watches was midnight to 4 in the morning. And out in the ocean, there's hardly any clouds. The clouds are on the horizon, and you see the sky. And every morning from it was in March 1973, and in the morning I saw Procyon and I saw Regulus setting, okay? And I could point the bowsprit of the boat right for those stars, and they took me to Hawaii. There was no GPS. No GPS. Way out of range of Loran. Loran's only near the shore. We had a compass, we had a sextant, we took noon readings and 2 o'clock readings and had logarithm tables, and we got to Hawaii using the stars. So that was a great introduction for me, but it was years and years later before I started to get into astronomy. I fell in love with the sky then. And later, I did a cross-country camping trip. And before I went, I picked up this book. It's called How to Identify the Night Sky. I'm going to pass it around. You can play with it, look at it. It's a really great book. It's an introductory book on the night sky. There's many of them out there. It doesn't really matter which one you get, but it kind of does. You want to get a pretty good one that describes. This book, by the way, is geared for binocular astronomy. Okay, it's almost everything in this book you can see through binoculars. Okay, but I started with this book and I got confused. It was way over my head. I couldn't figure out what was going on, so I had to study. I had to learn. I didn't go to any classes and stuff. And I kept reading the book over and over again, and I studied it, and finally I started to get it. And it took a while, but and there wasn't much good weather on this trip, so I spent a lot of time reading the book, and that's what I'm going to get into. Obviously, I chose this picture of Galileo. He's not at his telescope. He's studying. He's got his charts. He's writing something. Okay, he's at a desk or a table, and that's why I picked this, because part of astronomy is learning, is studying. Okay, another guy. Anybody know who this is? Hubble. Yes, one of the greatest revolutionaries in the science of astronomy. Again, I picked him studying. Okay, because you can't do it if you don't study and learn about what you're doing, okay? So get some star charts maybe. Go to the web. Wikipedia is absolutely incredible. There's so much you can get off Wikipedia. Maybe join an astronomy club. There's the American Astronomical League. You can go to them online. They'll give you lots of information. There are observing clubs that you can join. They have lists of objects that you can see and study in the sky. And you don't need anything more than binoculars. Okay, now no matter what you're interested in, armchair astronomy can be fun. Right. Okay. Yeah. We got a computer. We got some star charts. We got some lists. We got a planisphere. And we got our back scratcher. Real important tool. Okay, so what do we have? We start off with a list, all right? Now, you can get this list. There's 100 million different lists you can get. The astronomy clubs will send you. You can go online, download all kinds of lists. This happens to be the this is the Astro League, and this happens to be. No, it's not Messier's. It's the Garnet stars. The carbons. Oh, the carbons. Yeah, carbon stars. But what's this? Becky touched on it. Okay, this is a planisphere, and this one you can get up on Haleakala at the ranger station. It's geared for our latitude. Okay, it's basically a wheel that turns. Okay, that inner wheel is white. It turns, and it has an opaque horizon line. And down below, it has the months of the year, and it also has the times of the night. And say you want to go out on January 21st at 10 o'clock. Okay, you set it at 10 o'clock January 21st, and it gives you the sky. I'm going to pass that around. Play with it. Okay. And you can pick that up for what, $4, $6, $5, $9? Right. Yeah, I don't know. I was flying up the hill one year, and I gave him my card, and I got it. All right? And it's definitely a really cool tool because you don't need your computer. If you're outdoors, you could easily get Stellarium or something on your computer, but it's kind of hard to have your computer outdoors. So it's a real easy way. Now, you go to your list and say, okay, I want to look at some of these guys, so let's see if they're in the sky, okay? And basically, I just make a little list of what I want to look at tomorrow night, all right? Now, I put together my eyepieces. I got tools. the tools you're going to have, maybe a towel rad, maybe you're going to need your glasses, some nice warm gloves, a couple of filters, a timepiece is critical, a few extra batteries, a lens brush, eyepiece brush, and various other tools. Okay? But the first thing you want to do before you go out is make a list of what you want to see. Don't get too many. Now, that's actually a pretty long list. Okay? That's in one night, if you can see. As you can see, I did check off a few of those, right? But I also dated them when I checked them off. They weren't all in the same night. But for 410, okay, I have a name of an object, 1617 Draculus, and here it is in the page number on my atlas, my star atlas, which is here. Okay, I'll let you look at that. Maybe the coordinates are good. This is all part of your prep. How are you going to star hop to it if you don't have it in your scope? Okay, you're going to star hop from another star that's pretty bright, or if it's in your scope, the number that's in your scope, okay? The thing to do is to start easy and go to the more difficult, all right? Just pick really easy things for early in the evening and then go to those first, okay? Let's see, you make your list. And also, I like to do a punch list before I leave the house, okay? If I'm going to go out for the evening, I want to make sure I have my case and it's got my star atlas and it's got my eyepieces or whatever. I want to bring maybe a headlamp or food and water, some extra clothes. So I don't want to get up wherever I'm going and forget, oh, gee, I don't have my, my special gloves or something, and then you really can't do it. So make a little list, a checklist. And before you go out, you want to check the weather. Well, if it looks like that, what? Don't go. Right. But if it looks like that, chances are it's pretty good. Right? There's a little disturbance going on to the north. How did I get it to move like that? There must be a link. Yeah. But when you get out there, you notice on top of Haleakala, it's kind of fuzzy right there. So it might not be that great a night. Yeah, it might not be that great a night. But however, this is going to help you. You never know what you're going to find out when you get out there. When your backyard, all of a sudden the clouds come through and you're all done. Okay? But it's good to check the weather before you go. Okay? Maybe go with a friend. Try and find someone that you like, someone, family members, right? Even the smallest family member can participate. Right. Yeah. Now, when you get there, you want to set your scope up. You have a table. But you never know what you're going to see. Any surprises could happen, right? However, eventually, before it gets dark, right, you want to lay out your table, lay out your charts, your eyepieces, get your scope ready, whatever it is you want to use for the night. Have it all ready and handy so you don't have to run around to the car and find it. So make sure everything is sort of together. And you want to eat before you go. Right. Eat and drink. Dress properly. Yeah, that's right. A few extra layers always help. Okay? Now, you want to lay out your charts on the table. You have your list. You want your log. You want your star chart. You want maybe your planisphere. You want your timepiece, maybe a laser pointer, maybe a headlamp. If you're doing some calculations, it's good to have a little calculator. Guess what I use? People laugh. People hate it. They make me put it in my pocket. It's an egg timer because you're going to get so involved you don't want to stop, and then all of a sudden you realize you're cold. Yeah, so I set my egg timer at about 30 minutes. Yeah, when that goes off, I'm done. I got to go inside and warm up because I'll forget. And that's what's probably going to happen to you once you get into it. Your eyepieces and everything are all lined up. Okay? Now, you make your entries as you go. Let's see. Explain everything. Okay. So I'm going to start with a pretty easy chart. This is a chart that the astronomical lead provides. It's a 6-up, 6 different objects in one. And I'll go through these pretty quick. I've got them up here. You can look at them. It's the object, the date, the time, the instrument, the seeing. Basically, how good the seeing is, how well you can see. I could explain that for hours, but basically, if you can see fourth magnitude stars or sixth magnitudes, 6 is about as far as you're going to see with the naked eye. The power of your eyepiece in relation to your scope, and a quick description line, and maybe a little drawing. All right? Don't be afraid of drawings. Now, this one gives you north, but it doesn't give you east or west. So you've got to decide what that's going to be when you observe. Okay? Another one is another astronomical league chart. Here it's giving you more, you're putting in more information. Name, catalog number, type of object, constellation, location on the charts, and the source, magnitudes, listed size, telescope you're using, eyepiece, your name, date, time. And then you've got low power ocular. That's a low power eyepiece that's more, that shows more of the sky, okay? And then a high power eyepiece that zooms in on it, okay? And you do a little drawing, and then you make a description of what you're seeing. Okay? And on your handout, there's a whole thing on wording of descriptions, all right? I'm not going to dwell on that. The next one is, this one you can, before you leave the house, you can do a little sketch, maybe off Stellarium, or if you have a finder chart you can go to online, and it'll give you that object with some of the principal stars that are close to it. Just do a quick sketch before you leave the house. Then when you get on the field, do another drawing from what you actually see. Lots of room for notes. Here's a 2-up of the same thing. Okay? And then here's one put out by the Royal Astronomical Society of Canada. All right? And it's giving you there the type of object, open cluster, globular, various different types of objects, the magnitude, size, and instrument, eyepiece, filters. Lots of room for description. And then the last one is a sketch of the moon through binoculars. You can do that yourself. Okay? You're filling in all the blanks. This is about a half an hour sketch. Okay? And yes, it's one of my observing logs. And that's it for me, except I just want to finish up by saying that at the end of your session, you want to pack everything up neatly and cleanly, obviously. Make sure it's clean and dry. When you get home, open it all up again, clean it up, dry it out. Go over your logs the next day. Call or email a friend and let them know what you've seen, okay? If you're part of a club, connect with your friends and share what you've seen. All right? Good. Yay! Thank you. And I just wanted to say in this one, sorry, I'll quit here quick. Binocular sights for city nights. It's a great little article. I put a paper clip on it. You can come up and look at it. Okay? Good? Yes?
Can I ask, when you're describing these objects and so forth, so you're always looking at things like nebula or galaxies. You don't just look at a star, because it would just say star, star, star. It looks like a point.
Great question. Great question. You're talking to somebody who loves binaries. And binaries are a star that has another star orbiting it like a planet. Okay? So yes, you can do drawings of just a star and its companion star, or maybe it has 2 or 3 other stars. Or a small asterism of stars, which would be like the hockey stick. Yeah, that's a very, there's a asterism in the sky. I forget the constellation now. It's in the Pleiades, and it looks like a hockey stick. You can go to it in the Pleiades and find it, and then draw it. Yeah, so you're not necessarily drawing a galaxy or a nebula or a cluster. However, if you do get into the Messier Club with the Astronomical League, I'll pass this around. This is a Messier list that I'm working on now. And you can do sketches of all the Messier objects. You don't need a huge telescope to do it. Messier was an astronomer, and I'll quit pretty quick here, that lived in the 1700s and had his observatory on the roof of his building in Paris in 1730-something. And he was a comet hunter, but he wanted to find objects that were not comets. And he basically created the benchmark list of beginner objects that you can pretty much see with binoculars. You can see them all with binoculars. And so, yeah, there you go, the Messier Marathon. There's one night of the year you can see them all in one night, from dusk to dawn. Yeah, it's quite a project to do. But so good. I'll stop talking, but I have a lot of things up here for you to look at. Feel free to come up and have a look. Okay, thank you. Any other questions is good? Yeah.
I have a semi-general question. They repaired the Hubble about a year and a half ago.
Yes.
And now we're sending more space up and stuff, I guess. How long do they think the Hubble will last before it finally deteriorates? Is there a guess on that, or is it?
Joe may know. It's kind of a guess. They sent the 2 rovers to Mars, and they expected them to last, 6 months, and it's been 3 years, 4 years?
Oh, 5 years?
Yeah, the hope is that it will substantially overlap.
Yeah, the gyros. Batteries. They can't recharge the batteries. Yeah. Good. Any questions for Becky or for Casey or anybody?
Is it clear outside?
No.
Oh!
Okay. So let's give these guys a hand. I also want to
Thank you. You want this?
My friend Robert, who is the vice president of the Haleakala Amateur Astronomers Club, told me to mention the fact that our group gets to observe up on top of Haleakala, and through the courtesy of JD and Jeff, the people from the IFA, and in return, we do a lot of outreach for their group and for our group personally, HAA. And so we set up our telescopes for the public, and so Robert wanted me to mention that, that's our, we go up and observe to find dim fuzzy objects up in the sky and record them, but for the fun part of it is we get to have a lot of students and a lot of people who aspire to be amateur astronomers come up and look through our telescopes, and we really like to do that. Yeah. Like tonight, except I don't know if there's any stars out tonight.
No. Yeah. I was going. That's exactly what I was going to say. I wanted to give you guys a big round of applause, because the amateur astronomers in both groups have spent a lot of time. Have gone to a number of schools with me to help the kids learn about the sky and get them excited about science. Mr. DeVay, who's right here, is nodding. He can testify that these guys have been absolutely fantastic. So let's give them a round of applause for that as well. And since the sky is perfectly clear, and by perfectly clear I mean clear of stars, what we're going to do is we're going to break you up into about 2 groups, and if Natalia, you'll come in. Natalia is one of the Pan-STARRS observers. Those who want to stay here can go on a tour of the Pan-STARRS control room and kind of see what's going on. Apparently it's a very beautiful night up at the summit. Those who want to, and you can also take a look at the telescopes and equipment, see if anything happens to show through a hole. But I've got the lights turned out. If anyone's planning on leaving, grab one of the amateur astronomers or myself, just so we make sure you get out safely. All right? Okay, thank you for coming.
Thank you. Yeah, pleasure.
Nice.
Fun. Mm-hmm. Yeah. Here's your